covered most of the things. Yeah, let's have a look at the IO slots. See this one that you see, I'll read out the model number. It's AAB841S00. This is an analog unit, okay. ADB551, that is a digital unit again, okay. What you see over here, this is called as the case cable or the prefab cable, okay. When it's digital, it's called an AKB cable instead of case, but it's still a prefab cable. Now what this does is it has a bunch of wires or bunch of inputs that's obtained from your marshalling cabinet. Yeah, this is your marshalling cabinet, okay. You have a lot of inputs from the field that the transmitter emits coming into your junction box. From your junction box, all these wires come up again as a prefab cable, and it is bounded up into your marshalling cabinet. From your marshalling cabinet, you again pick up a case cable and pass it on to your analog IO unit or digital IO unit, whatever, fine. And the communication happens back to your MCU. All those things happen, fine. Now let's have a look at how the FCS is connected with your HIS, okay. I have shown you PFCS and I said it uses a VLNet connection. Now your LFCS and your KFCS, they both use a VNet connection, okay. But your HIS, it won't use a VNet actually. See what happens. This is another interesting thing. This is a ferrite core unit. What it does is all those noises and things that are present, it can be reduced using this ferrite cores, okay, fine. So let's have a look at how this thing is connected to your HIS, okay. This blue wire comes down to here, and what you see over here is your straight connector. This connects your VNet to your VLNet. Remember the thickness that I said, 2 mm. This is 5 mm, okay. It converts it into VLNet, and this goes down back to your desktop, which serves as the HIS, okay. Now you have a T junction over here. One end is terminated with a 50 ohms resistor, and this is where your VLNet comes back or joins to the HIS. Now these two units that you see, there is a card behind it. It's called a vehicle interface card, okay, or HIS interface card, and the model number that we have used over here is VF701, fine, okay. Alright, so we have covered even your NIU, and this sort of connection is similar for your KFCS and your LFCS. Anywhere you find a VNet, the connection has to happen this way. There should be a straight connector converting it into your VLNet, going back to your HIS using a T connector, and entering into your vehicle interface card, fine, okay. Now let's move on to the next in series, which is your FFCS. What you see over here is your FFCS AFF50D, okay. Now there is a significant difference. You see it's more organized, and if you remember in the earlier sections, the FCU did not host any of the IO units, but here I'm telling you, this is your FCU unit. Here you have your power supply, you have your CP cards, here you have your communication cards, and see, IO slots are available. The concept goes like this: you have 12 slots, you can use all of them, okay. See, my power supply, CP and communication requires just 6, so the rest 6 can be utilized for your IO slots. So starting from your FFCS, even your FCU can host your IO slots. And again you have your NIUs, which just requires, 2 power supplies, 2 communication cards, and rest 8 slots, they can be used for your input output units, fine. Now if you remember, there used to be DIP switches in your CP units for addressing. That is taken care of by the desktop or the HIS, okay, in this case. And another difference is your communication, your bus, the pin has changed. Till now we were having a VNC pin. Here we have an RJ45. Okay. Now let's see how the connection comes from your HIS or your human interface. Fine. Your human interface gives the connection in a VLNet cable. Okay. What happens is, as I said, here you have a RJ45 pin, here you have a BNC pin, so a coupling is required, and this is your coupler unit. Okay, you give your connections over here. This is not used, it's terminated. You pick up the other two lines from the RJ45 section and connect it to your CP cards. That is how the communication happens. Okay, and coming to your communication cards, see, you just have a extended serial bus simply coming over to your communication card slot again in your NIU. Okay, the rest of the concepts are same. You have an SB401. This is EC401. Yeah, this is also another difference. This is an enhancement. So your FCU, it should start with an EC401. Okay, and this is for FCS. For FCS, the communications cards should start from EZ401. Okay, but rest of the concepts are similar. I mean, it's always SB401, but in case you have a remote unit, then it becomes a EB401 and EB501 in your remote node respectively. Okay, fine. See, this is your VLNet. What is this? This is actually your CAT cable, that is category 5E cable or an Ethernet cable. This was still, I could say, in the olden ages of internet. Okay, so they didn't think about having a single Ethernet card at this point of time. They still wanted to use your VLNet, but they added a feature wherein the coupler will communicate with your CP card using your Ethernet cable. In the next version, or the FFCS large, this is eliminated. That is, this conversion is eliminated, and it's called VNet over IP. We'll just have a look into that. Okay, this is your FFCS large, model number AFV10D. This is your VNet over IP connection. See, if you notice, there is no coupler. Okay, just two power units, two CP cards, your communication, which is again EC401. From here onwards, it's a standard. It is EZ401. Okay, then you have your IO slots.